All right, we are solving the practice test. Okay, so number one, this is a trick question because the leading term is this one. Okay, it's not necessarily the first term. It's the term with the highest exponent. So now, if the leading term is 4x to the fifth, I want to test the negative side and the positive side. So for the negative side, I put in an arbitrary negative number, like -1. And I say, all right, 4 times -1 to the fifth is -4. 4 times +1 to the fifth is +4. The value itself doesn't matter. What matters is whether you get a positive or a negative result. So since we got a negative value here, we say limit of f of x as x approaches -infinity is -infinity. Limit of f of x as x approaches +infinity is +infinity. I am still seeing on the quiz, for example, different variations of this notation. And I've marked down that points will be taken off on the test, and they will be. This is the notation we need to get used to, okay? All right. State the number of possible real zeros. Well, that's 5. You just want the number, not the actual zeros, the number, 5. And the number of turning points is 5 minus 1, 4. So really, this entire problem should only take you, less than 2 minutes, okay? All right, here, this should say for questions 2 and 3. And we want to determine whether the binomials are factors of f of x. So we're going to synthetically divide. And how do we know if it is a factor? If the remainder is 0. So here we have exponents of 4, 3. We're missing the 2. So watch out for that. So I have 1, 2, 0, -13, and 15. 1 comes down. We have 3, 5, 15, 15, 45. What do we get here? 32 times 3, 96. Clearly, this is not going to be 0. So the answer is no. Okay, I'm not necessarily concerned with, the actual value at this point because I haven't specifically asked. Yes?
If you forget to put the 0 in,
it's wrong.
No, it's like completely.
It's not completely wrong, but it's not fully right either if you forget the 0. Okay? If you do the synthetic division wrong, if you forget to put the 0 here, but you still get that it's no, it's not fully correct, right? Because the work is wrong. I mean, you just sort of lucked out, okay? All right. Here, we're dividing by -I. And when you're doing that, leave some room, right, horizontally. So we have exponents of 3, 2, 1. Are we missing any?
0.
The 0 at the very end. So it's 1, 3, 2, 0. You must put that 0. And we're going to get 1 minus I. When you add, you get 4 minus I.
Wait.
I'm sorry. You multiply, you just get -I. And here we get 3 minus I. When you multiply by -I now, we get -3I. -I times -I is positive I squared, which is -1. Okay?
So what is 1 times -I of I?
It's negative. The negative just didn't show up, but the rest is right. The inking, no. Okay, so -I times 3 is -3I, right? -I times -I is positive I squared, which is -1. Okay? So now we're going to get -3I plus 1. And when you multiply, what does that give you? -I times 1 is -I. Okay, so here, right, it's -I times -I, which is positive I squared. Okay? So where are we now? Negative I times negative 3I is positive 3I squared, which is negative 3. So this is negative 3 minus I. Again, it's no. Okay? Yes, absolutely. Okay. Divide using polynomial long division. I've specified polynomial long division. That's what you have to do. If you do synthetic, it is 0 credit. Okay? All right. So here we have x minus 4. 5x to the 4, 3, 2. We're missing the x term. So here we have 5x to the 4 minus 3x cubed plus 6x squared plus 0x plus 12. 5x to the 4 over x, you get 5x cubed. You multiply everything by 5x cubed, you get 5x to the 4 minus 20x cubed. Now, what we've been doing is changing the sign so we can add. So we get 20 minus 3, 17x cubed. And then the 6x squared comes down. 17x cubed over x, we get 17x squared. You multiply x minus 4 by 17x squared, and you get 17x cubed minus 4 times 17 is 68 x squared. We want to subtract, and it's easier to change signs and add. So 68 plus 6 gives us what? 74x squared plus 0x. 74x squared divided by x is 74x. 74 times negative 4 is negative 296. We want to change the signs to add. So here I get 296x plus 12. 296x divided by x is 296. And now what we get is 296x. And then we have 296 times negative 4. Negative 1184. We change the signs. And we get negative 1172. And that's your, oh no, sorry, we were going the other, we're adding. 1196. So that's my remainder. Now, on the test, if I put, on the test, numbers will be more manageable, right? So I reserve those problems for the test. So, I put like the B list on the practice test. All right, so the answer now is going to be 5x cubed plus 17x squared plus 74x plus 296 plus 1196 over x minus 4. Okay. If you don't have the parentheses themselves, that's fine. But the x minus 4 should be there. If the factor is an I, we would do synthetic division. It doesn't make sense to do long division with an I. It's just too complicated.
So this is a factor?
No, this is not a factor. Yeah. Yeah, it's not asking for that. This is just a division exercise. That's it. Okay. Describe the number of possible positive or negative zeros, and you're going to fill out the chart here. Now, in the chart, I've just put in 3 rows. You may use all 3, you may use 2, you may need 4, in which case you add another one. I just put a generic 3 rows. Okay, so let's just go ahead and do this one. All right, so we need to know how many times this changes sign. There is a sign change here. There is a sign change here. So for positive, it's either 2 or 0. Okay? So here I put either 2 or 0. All right, what about for negative? For negative, I want f of negative x. Now remember, the quick way to do this is those with even exponents will not change. Those with odd exponents will just switch sign. So it's negative 4x to the 5th plus x to the 4 minus 2x cubed minus 8x squared minus 16x, and the constant can't possibly change. So now the number of times that there is a sign change is 1, 2, 3. Okay? So for negative, we either have 3 or 1. You must always go down by 2's until you can't subtract 2 anymore and get a positive number.
Yeah, I feel like it's more helpful for me to do this alone than to see what I'm lacking in and ask you about it later.
Okay. No, you can't work outside. But if you want to go ahead here, you can. All right. So what I'm going to do here is, because I have 2 options for the negative, I will split this up for the 2 and split this up for the 0. Okay? So in each of the cases, I have 3 or 1 and 3 or 1. Okay? Because you could have 2 positive with 3 negative or 2 positive with 1 negative. You need to take all the different choices. All right, so now how many do each row have to add up to? What's the total number of zeros? 5. So they each have to add up to 5. So 2 plus 3 is 5, leaving us with 0 imaginary. Okay? 2 plus 1 is 3, leaving us with 2 imaginary. Because total has to be 5. 0 plus 3 means we have how many imaginary? Oh yeah, 2. And 0 and 1? 4. So just make sure that the column for imaginaries only has even numbers or 0. You can never have 3 imaginary solutions or 5 imaginary solutions. They always come in pairs. All right? Questions? Okay. So write a polynomial function of least degree with real coefficients in standard form that has the given zeros. All right, we have 2 zeros given and an I. We need to add negative I as well. All right, so it needs to have a total of, what's the degree going to be at the end? 4. Okay, so x minus 4, x plus 1, x minus I, x plus I. Now, here, just do the first 2. This is basic FOIL. We're going to get x squared minus 3x minus 4. Okay? Here, it's going to be x squared. Now, because it's a minus b, a plus b, it would be x squared minus I squared. Negative I squared is what? Positive 1. X squared plus 1. Okay? If you need another intermediate step there, you can always add. Now we're going to multiply these. So first multiply the x squared, and we get x to the 4 minus 3x cubed minus 4x squared, and then the 1. Okay, so we get x minus I, x plus I going back. This is going to be x squared minus I squared. Okay? So it's x squared minus negative 1 x squared plus 1. Okay, so here when we simplify, x to the 4 minus 3x cubed minus 3x squared minus 3x minus 4. Okay? All right. Now, when you see one like this, first thing you want to do, factor everything. So here, I'm going to factor the top, and I'm going to get what? X plus 3x minus 1. In the bottom, I have x times x squared minus 3x plus 2, which factors to x times x and x. Now I need to add to x minus 2x minus 1. Oops. So what happens now? The x minus 1's cancel out. What does that mean? There is a hole at x minus 1. Excellent. So the completely factored form of f of x then is x plus 3, x times x minus 2. There is a hole at x equals 1. Yeah, there is a hole at x equals 1. All right. All right, state the domain. So for the domain, we're going to go into this step, right? X cannot be 0, it cannot be 2, it cannot be 1. So our problem points are 0, 1, and 2. We already established that there's a hole here, all right? But still, it's a problem point. So my domain is negative infinity to 0, 0 to 1, 1 to 2, 2 to infinity. For the zeros, we're going to set the numerator equal to 0, meaning it's the factored form, x plus 3 equal to 0. So x equals negative 3. You ignore the hole, right? The 0 is where it crosses the x-axis. There is no graph at the hole. Huh? The numerator, y-intercept, if any. Okay? For the y-intercept, you plug in x equals 0. Well, because the first one is the domain. The domain is give me all of the x's where there is a graph. Okay? And for that, you want here, because you want to include all of the points where it doesn't work. Right? By the time we got to here, we lost some of that information where it didn't work. Okay? But for the zeros, so if you had gone here for the zeros, you would have said x equals negative 3 and x equals 1, right? But there was a hole at 1. Okay, so plug in x equals 0. So let's see. 0 plus 3, again, we're working with the last one, over 0, 0 minus 2. What's happening? It's right, it's 3 over 0, which is undefined. That means no y-intercepts. You can just write none. Next, vertical asymptotes. So here, vertical asymptotes are you get them from the parts of the denominator which did not cancel. So now you set the denominator equal to 0, which is x times x minus 2 equal to 0. That means x equals 0, x equals 2 are your two vertical asymptotes. You will lose points if you don't say x equals, if you just have the numbers. Yes?
So is the domain the only time, when you find the domain, is that the only time you work with the not completely factored, right?
The domain and the horizontal or oblique asymptotes.
So those are the only times
Mm-hmm. Right.
How'd you get x equals 0?
Well, because you have an x here, you set it equal to 0, and it's just 0.
Oh, okay, so you do each individual part.
Right. Find the coordinates of the holes. So we established before that there was a hole at x equals 1.
Wait, do we have to show like this work on the
This one, the denominator equal to 0, that part. You don't have to show this. No, I'm doing these just for you. I mean, look, the more work you show, the better it is for you. Okay?
Remove this one.
Yeah. So the whole, okay, so it's at x equals 1. Now we're going to plug x equals 1 into function. And we're going to plug it at x plus 3 over x minus 2, right? So 1 plus 3 over 1, 1 minus 2. This is 4 over negative 1, negative 4. So it's at 1 comma negative 4. Okay? All right, so that's where that is. Okay, find the horizontal or oblique asymptotes, if any. All right, so what do you think? Does this have, not what do you think, but does this equation have a horizontal or an oblique asymptote? It's either or.
Horizontal.
Why horizontal?
Because the denominator is the greatest degree.
Right. Okay, so when the denominator has a greater degree or an equal degree, it's a horizontal asymptote. All right? So this is a horizontal asymptote.
when the denominator degree is higher than something?
Yes. So we say the limit as x approaches infinity, and we want to take the term with the highest degree from the top over the term with the highest degree from the bottom. I want to see this. Okay? So what does this mean? Limit as x approaches infinity, when the x squared cancels, it's 1 over x. That means it's y equals 0. Okay?
Would you have to show the end behavior part? Or
You have to show this part. Okay?
you can't just say that we
No.
know that if the bottom is bigger, you have to do it with that behavior.
No. I mean, the amount of ink or lead it takes to write all that, you could just put this on there.
No, I know. I don't understand
Yeah.
that as much as I understand the rules that we learned.
Okay. So the asymptote, we have a y equals 0 horizontal asymptote. And the vertical ones were at x equals 0 and x equals what? 2. Okay. So let's put that there. There is a hole at 1 and negative 4. 1 and negative 4. You must put that one there.
Why negative? Oh.
Okay, now, where's the 0? At x equals negative 3. 1, 2, 3 here. Okay, so let's examine this for a minute. The fact that the hole is here, that means in this region between the two asymptotes, the graph lives downstairs. Okay, that means it's going to look like this. Okay.
Why do you know that?
Okay, why do we know that? Because there's a hole there, that means it's going to cross this point 1 and negative 4. Can it possibly cross the x-axis and go up? No, because there are no zeros there. So if it's going to cross here, and it's going to follow the asymptotes, and it's not going to cross there, that means it's got to go down. So now, if it goes down this way, then to the right of the asymptote, it has to enter from the top, and we know that it's going to follow the asymptote there. Now, here's the most exciting part of all. What about on this side? Okay, to the left of this, it's going to enter from the top, but it's going to come over and cross that x-axis. That means it dips down, and then it has to come back up to follow the asymptote. That's the best play of the game. Okay? Okay, so I'm telling, okay. So Do we understand why it has to come down here and then enter from up here? Right? Okay. You can absolutely plug in points. But you see how quickly I did this without plugging in any points? Okay? Okay, so look.
The whole point of an asymptote is that it couldn't do that.
Okay. So here we're going to move everything to the left side. And we get 2x squared minus 10x. Well, minus 12x. Whoa. Why can't I erase? Plus 16, less than or equal to 0. We factor out a 2. The 16 moves over. I'm subtracting 2x and adding 16. Right? So x squared minus 6x plus 8, less than or equal to 0. And here we have minus 4 minus 2. That means what points go on my number line?
4 and 2.
Right, or 2 and 4. No, oh, that 2, yes. This 2 can be ignored in this case. Okay, so let's pick numbers to put in here. Suppose x equals 0. All right, you can plug it into, either the parentheses or this original equation. In the case of x equals 0, it's easier there. Do you get positive or negative? Positive. Now, add x minus 2. What's the multiplicity? 1. The multiplicity is 1. That means it's odd multiplicity, so it's going to alternate from positive to negative. At 4, the multiplicity is odd, so it's going to alternate to positive. Okay? If you forget this, if you have no clue what I'm talking about, can you just plug in x equals 3 and plug in x equals 5? Absolutely, and you get the same thing. Now I want the value where it's less than or equal to 0. So it's in this region, 2 to 4. Brackets.
And it's brackets because it's
Less than or equal to. Yeah. Here, if I factor this, I get x times x minus 3. So what I want to do first for plugging in, into the sign chart, I want to move everything to the left side first. So I have 14 over x times x minus 3 minus 8 over x. Well, I want to do it now because it'll help us later. Okay? Yeah, I want to move it over now. And I'm going to move this over, so it's going to be plus 10 over x minus 3. No. The denominator can't change. It's only the sign of the numerator that can change when you add or subtract. So we're going to multiply everything by what now? X times x minus 3. Okay. Here, when you multiply by x times x minus 3, the whole denominator goes away. Minus 8 times x cancels, so you have x minus 3 plus 10x. So we have 14 minus 8x plus 24 plus 10x less than 0. So here I have 14 plus 24 is positive 38. Plus 2x is less than 0. Right? Where I'm combining like terms. So 14 plus 24 is 38. Negative 8x plus 10x is 2x. So when you solve that, what value do you get for your x? Negative 19, right? What other values do I put here? I put in the values from the denominator, right? So 0 and 3.
That combines the
Huh?
the least common.
So here, when you have a denominator, you also have to put in the zeros from the denominator. Okay? So now, how many, we get 1, 2, 3, 4 values. Okay, so let's plug in an easy number. What's an easy number? We can plug in a 1, right? Let's plug in x equals 1. And this is why I moved it over, because I want to plug it into here, into this step. Okay, so let's plug in x equals 1. And what do I get when I do that? 14 over negative 2 minus 8 plus 10 over negative 2. Is that a negative or a positive number? I have a negative minus a number, so it's negative. So that was here negative. Okay. They all have odd multiplicities, so they're just going to alternate. So positive, negative, positive, negative. Now, I want less than 0. So I want the negative ones, meaning negative infinity to negative 19, 0 to 3. So this is one that's more challenging than the ones on the test. Okay? All right, what about this one? Can you factor this?
No.
And when you do quadratic, you get imaginary solutions. Meaning you can't put anything on the number line, but you make a makeshift number line anyway. All right, so if x's are positive, will you get a positive or negative y value? Here, positive. If x is 0, it's positive. And the negatives, so this is positive everywhere. Now the question is asking you for numbers greater than 0, so it's all reals.
But if the sign is less than the
Okay, so let's see. Let me do this one, number 13. I do have solutions on haiku already. Yes, I have a blank one and solutions on haiku. So here, we're going to multiply everything by 20 times x plus 1. I think 15. This has 16, so 15. Okay, but if you think about it, like we started this so late into the period. 100. So it'll be, yeah. And you know, like one of those have, a couple of them have multiple parts. Okay, so here we get 20x times x minus 20 x plus 1 x minus 1 equals x times x plus 1. 20x squared minus x squared. Right, because it's 20x times x. It's a 20x. No, I'm multiplying the whole thing. No, I'm multiplying everything by 20x times x minus 1, x plus 1. I got sidetracked by a question by somebody. All right, so here, I like this problem because the x squares go away. So these go away, and now I have x squared plus x minus 20 equals 0, x minus 4, x plus 5, so x is equal to 4, x is equal to negative 5, right? And is that okay? Is that part of the restrictions? No. So that's the answer. Okay, all right, so that's time. And like I said, the rest are similar. And number 15 is very easy.
Wait, were the instructions just
Oh, we have 10 more minutes. Oh. No, I would have caught it. I would have caught it. Okay, so what are we doing here? We're going to factor this, so it's b times b plus 1, right? So I multiply by, I'm going to multiply the whole thing by b times b plus 1, okay? All right, so here I get 3b plus 1 plus 2b equals 23. So here we get 3b plus 3 plus 2b equals 23. 5b equals 20. b is equal to 4. Okay, the last ones are roots. First we're going to isolate the roots, so we're going to subtract by 3 on either side, and we get cube root of 4x plus 8 equals 4. Now what? Raise everything to the power of 3. That gives me 4x plus 8 equals 64. 4x equals 56, and what does x equal to? 14. Okay, now, this is a cube root, and what's the domain for cube roots? What does the equation look, what does the graph for cube roots look like? So what's the domain? X, the domain is all reals. Right. That's just the square root. So if the domain is all reals, that means we have no issues. So whatever answer we get should be okay. All right? Okay, next one is not the case, right? Next one is a, what do you call it? It's a root. So, up or down? Okay. So the, when we get the answer, we have to check for extraneous solutions here as well. So most common mistake is students will see this problem and they will start squaring right away. What's the issue there? You have to isolate the root first, because if you start squaring here, then it's a mess. Then when you square, you still have a root, and it's just a mess, and you end up with x to the 4s. Okay? So first you isolate the root, meaning you have to take the 3 to the other side. Leave the root alone. So here we have 3x minus 3 is equal to the square root of 18x minus 18. Okay? And now you take a square of it. Now you square. So here, what do I get on the left side? 9x squared minus, it's 2 times 3 times 3, so it's 18x plus 9 equals 18x minus 18. Okay? Meaning, all right, so when we move the 18x over to the other side, and the same with the 18, we get 9x squared minus 36x minus 27 plus 27 equals 0. And now what? We can factor out a 9. X squared minus 4x plus 3 equals 0. X minus 3, x minus 1. That means I have x equals 3 and 1. Now I need to check. All right, so let's check x equals 3. Whenever you have a root equation, you must check. Only roots. Okay? Okay, so we talked about 15 at great length, right? It's cubed. It's a cube root, meaning the domain is all reals. So whatever answer you get is going to work because you have no restrictions on the domain. Because this is what it looks like, right? Meaning like it's continuous everywhere. Okay, so here we're going to check x equals 3. So we say, all right, so 3 times 3, is this equal to 3 plus the square root of 18 times 3 minus 18? And this is 36. So 9 equals 3 plus the square root of 36. That works, right? Okay, so, okay. Who has a question? Yeah. No, that's only when you have like x squared equals 9 and you take a square root. That's only when you're solving an equation. When you're just evaluating an expression, you don't do plus or minus. So the next one is x equals 1. And now we're going to get 3 times 1. And we want to see if that is equal to 3 plus the square root of 18 minus 18, which it is. So it's also equal to 1. Okay?